Thank you very much, Mark, for that introduction. Also, Melanie, for organizing this symposium. It's been fascinating, and a lot of what I'm going to say has been said beautifully by the previous speakers, but so I can shorten some of that. But I'm going to talk a little bit more broadly about the problem of air pollution and how we can, by reducing all of the emissions of fossil fuel, burning of coal, oil, diesel, even natural gas, how we can achieve great benefits to children's neurodevelopment in the immediate, in the present, over their life course and for their future. So this is going to start very broad and holistically, so bear with me. And then we'll bore down a bit on some of the research, more focused research at our center, and then try and cheer us all up with some of the solutions that are actually working on the ground and some evidence that they do work, and they do good and they do well. I guess I should say do well and do good economically, but anyway, you'll see. So I'm going to start with these sayings, the Native American proverb, and the quote from John Kennedy the summer before he was killed. We don't inherit the earth from our ancestors, we borrow it from our children. That's the Native American proverb. And children are the world's most valuable resource and its best hope for the future. And that's the philosophy and value I think that we all share. And so let's think about how we are doing now for children and how we can do better. So I'll talk, as I described, about emissions from fossil fuel combustion in the broadest sense, not only the toxic air pollutants, but also CO2, carbon dioxide, the main driver of climate change. And as I say, the burning of these fossil fuels contribute the vast majority of both toxic air pollutants and CO2. So we should think of them holistically. We should think of fossil fuel combustion byproducts holistically and the benefits as well. So we know that fossil fuel represents 80% of total primary energy supply. Now, we've seen some good news with indoor air pollution declining in recent years, but outdoor air pollution continues to climb, about 8% a year. And we now have 300 million children globally living in areas where air pollution levels exceed the current World Health Organization standard for particulate matter, 2.5, by at least six-fold. And that's a sobering number, isn't it? And then in the US, more than 39 million children are living in counties with unhealthy air quality. So the toxic air pollutants include these that other speakers have discussed. It's a rather long list, including the particulate matter, the polycyclic aromatic hydrocarbons, or PAH, nitrogen dioxide, mercury, and others, and all of these are known to be neurotoxic. And also riding along with them out of smokestacks and tailpipes of vehicles, etc., are the gases carbon dioxide, methane produced during the production, transportation of fossil fuel, and actually in a staggering amount of 32 billion metric tons of CO2 every year. And we should think in these, as I say, holistically, think of synergies, because in the presence of higher temperatures or changes in rainfall frequency, stagnation of air, extreme weather events, we have accelerated formation of ozone, that's with the higher temperatures. With forest fires, we have more release of particulate matter and black carbon, adding to the loading from the on the left side of your screen for the directly emitted toxicants. Now we know that the burden of neurodevelopmental disorders in children has been increasing, and that's in the US and that's globally, and not only because of better diagnosis, such that 15% of American children are affected by at least one neurodevelopmental disorder. ADHD affects 10% of children in the US with a very large societal and individual cost. And the global prevalence of child and adolescent mental disorders has reached 10 to 20%. And as I mentioned, the rates have been increasing. So, what are these outcomes? We've been hearing about them. They do include all of the examples you've been hearing about from the earlier speakers, and including the ADHD, autism, and learning intellectual disabilities, and then disorders of conduct, anxiety, and mood. Example, depression in children. Well, the challenge, as Irva has and others have mentioned, is the multi-factor etiology, and the fact that you cannot identify any single cause, but we have focused on environmental exposures, which alone or through interactions with genes, as we've heard, are very important because they are eminently preventable, by nature preventable, once they're identified as harmful. So, and frequently, as we've heard, they co-occur and can interact also with toxic social conditions, nutritional factors, infectious agents. But as Irva mentioned, intervening on any one of those could disrupt the cycle or the relationship with the disease or disorder. And we know a lot now about the susceptibility of the fetus and child, the very rapid, highly choreographed, highly programmed development of the brain and other systems, the lower ability to clear and detoxify chemicals, toxic chemicals, and to react to infectious agents or stress. The immune system is not functioning as it is in the adult. And very importantly, chronic diseases can be seeded prenatally or in the early years, and even effects can be inherited transgenerationally. And we see the same factors are placing the young at higher vulnerability to psychosocial stressors experienced by the mother or the child. And this is, I think, a slide that you showed, Ted, a version of it showing how very complex and the brain development is between the periods of conception and birth, how many very critical pathways, events are taking place from the formation of the neural tube to the developed brain at birth. And that process, several of those processes do continue into childhood and even adolescence. But you can see that the vast majority of the structure of the brain is laid down even prenatally. So there are great opportunities for disruption of this very precise process. And the health effects associated with air toxics are many. And they do include these neurodevelopmental effects. And those associated with climate change also include neurodevelopmental effects, mental health problems. And those mental health problems or disorders are due to things like malnutrition, not just causing stunting of the body, but also stunting of the brain, also psychological trauma. And so we can't think of these separately. We really should be thinking holistically. And that's because when we intervene on the common source, we gain all of these benefits for children. And an example is a child who has been affected by air toxics in terms of early brain development will be more vulnerable to those impacts from climate change that I mentioned earlier, and there are many other examples, such examples why we should be thinking holistically. And the long-term impacts is a really important theme of this meeting and a real concern that the effects of toxic air pollutants don't just go away in childhood, as we know, that the problems often persist into adulthood. That's true for climate change impacts, leading to impairment of cognitive functioning and learning. And it's also true for the stress, psychosocial stress, from living in areas that are high air pollution or areas that are affected by climate change that can also contribute to these long-term impacts on mental, cognitive, and behavioral functioning. And in terms of environmental justice, what we are seeing is injustice on multiple fronts, not only disproportionate exposure of the poor and certain racial groups, And remember that almost half of the world's children are living in poverty today. And in the U.S., the most wealthy economy in the world, 22% of children are living in poverty. And along with poverty, of course, come these stressors that can interact with environmental toxicants. And I will show you a couple of examples from our own work. And then the dual, or I say multiple injustices, is that children bear the brunt. The World Health Organization estimates that children from 0 to 5 years bear 40% of the burden of environmentally related disease globally, and 88% of the burden of climate change-related disease or disorders. So we have inequity on many fronts. Now, there have been associations observed between multiple air pollutants and these adverse cognitive behavioral mental health outcomes. For particulate matter, for 2.5, NO2, nitrogen dioxide, for polycyclic aromatic hydrocarbons, for PM10. And the associations have been significant in many studies, not all, but as we've been discussing, there are reasons why there may not be complete consistency. But these associations I mentioned because they're quite strong, and we have to pay attention to the fact that they're also emitted from many of the same sources. So I'll focus now on polycyclic aromatic hydrocarbons and the multiple mechanisms that they can exert. They're genotoxic. They form DNA adducts shown in that little cartoon with the black blob signifying benzoapyrene, one of the representative PAHs. And if not repaired, those lesions can go on to cause mutations and ultimately cancer or other problems. They also can generate reactive oxygen species, which can damage DNA. But in addition, they're endocrine disrupting chemicals that can act to interfere with the normal hormone regulatory systems, pathways in the body, so important in early development, and also disrupt glutamate's signaling and activate the glial cells that then may become neurotoxic. So multiple mechanisms and not mutually exclusive. So versatility is one of the emblems of PAH and so many other pollutants that are emitted from fossil fuel burning. So I'll just give you some examples of the results of research at our Columbia Center for Children's Environmental Health, cohort studies in several countries, in New York City, in Poland, in Krakow, and in China. This example is from Chongqing. And there is consistency across these different birth cohort studies in the observation of an association between PAH, prenatally, and adverse birth outcomes, cognitive behavioral problems, and where we've been able to look in detail, asthma and respiratory problems. And that's across a gradient of exposures and in different ethnic racial groups. At the center in New York City, we have 3 different ongoing cohort studies that are all part of ECHO that you heard about, this virtual cohort nationwide, funded by NIH. And they include this Mothers and Newborn study started in 1998. So the oldest children are now 21. And it's been a very exciting trip, seeing them grow from, oh, I saw you when you were in your mother's arms, and now here you are. And it's been wonderful. And then a sibling hermanos study, those younger siblings, and then a new cohort that was launched in 2013 called Fair Start. And we expect to have 1,500 mothers and 1,500 children enrolled by 2023. And these are molecular epidemiologic studies, so it isn't just going out to recruit and then use regional air monitoring data. We are delving into the molecular, at the molecular level as well. And we measure PAH exposure in a number of ways. Well, questionnaires, area and residential monitoring, and GIS. Personal exposure measured using these small backpack monitors during pregnancy. And then urinary PAH metabolites, PAH DNA adducts, which I mentioned, and also hemoglobin adducts formed by PAH. That's something that we're starting to look at. So what we see with all of these measures is considerable variation between individuals in these studies, and that no, we do not have a clear control group, pristine, unexposed group, as you can imagine. So we are looking across a gradient of exposure. And in New York City, we enrolled 720 mother-child pairs, and we excluded smoking, active smoking, and health conditions that might affect our results. African American and Dominican are the ethnic groups. That's the predominant ethnicity in our catchment area. Low educational status in general, and mostly low income. And we did recruit during pregnancy and collected the urine and blood from the mother, also cord blood and placenta at birth, and then blood and urine are collected over the child's years, all the way through adolescence. And you can see these spots are where these are the birth residences of women in our study, women and children in the study. Now, what we have seen with respect to the neurodevelopmental impacts, we've also looked at other outcomes, but here they are. With prenatal exposure to PAH, either monitored with the backpack monitors, as you see, or with the DNA adducts, we see that there's not only there are adverse birth outcomes, and also a number of neurodevelopmental problems, from delayed development to reduced IQ, and that reduction, on average reduction of 3 to 4 points IQ, is in the range of low-level lead, so certainly of societal concern in the case of lead, and I believe for these pollutants. Behavioral problems as well, symptoms of anxiety and depression in the children, as well as ADHD, and decreased emotional regulation capacity, and also some brain changes on MRI of the children related to prenatal exposure. And then interactions have been seen between prenatal PAH exposure and material hardship due to poverty, both on IQ and on ADHD symptoms. And all of these analyses have taken into account potential confounders and important contributors. This next, and also asthma and allergic sensitization. Now, this is a little excerpt from a recent paper that, not so recent, yes, recent, 2018, on prenatal PAH and reduced emotional self-regulation of the children when they were tested, tested all the way through age 11. And the prenatal exposure was associated significantly with decreased emotional self-regulation, and also with the social competence measured on the screening tool, social responsiveness scale, which is one of the screenings for autism. And so the conclusion is that there's some evidence that this impact on self-regulation mediates the association of exposure prenatally to PAH with social responsiveness. And that is being continued with the follow-up of the older children. And this is the result of a small pilot study that was published back in 2014 that showed a dose-response relationship between prenatal PAH and reductions in local volumes of the cerebral surface, and that those changes were confined largely to the left hemisphere, and they derived from underlying volume reductions in white matter. The analyses did correct for multiple comparisons as well as confounders, and were significant. And I mentioned, as I say, a dose-response relationship. Now, this work has been expanded to include the cohort, the total cohort. These kids were 7 to 8 years of age, and the cohort has been imaged at ages 9 to 12, and those results are being analyzed now. And Brad Peterson, who's now at USC, I always get the, yeah, is doing these analyses, continuing to collaborate with us. So effects of of prenatal PAH have been observed in the Krakow cohort, a higher level of exposure, a different ethnic group, and using the same methods of assessment. And here too, we see multiple impacts, both on birth outcomes, on neurodevelopment, and the intelligence scores, reduction in intelligence scores in this cohort were very similar to those we saw in New York City. So a confirmation, if you will, of that effect that we observed in New York, and also reduced verbal IQ, behavioral problems, and an interaction of PAH with material hardship and maternal demoralization, both associated with poverty, on IQ reduction and behavioral problems, again, significant with adjustment for confounders. So then we turn to, and the effects on the respiratory system. Now we turn to, here's where we can start to cheer ourselves up a little, because this is a good news slide in the sense that we were able to track 2 cohorts. The first cohort of mothers and newborns, and this is in Chongqing Municipality in China. The first cohort was enrolled before the power plant that was located in the central city was closed. The government shut that down. It was highly polluting. There was public distress and even some, I would say, some protests. And then also economically, this plant was not viable. Now, it doesn't look very large, but it was completely uncontrolled and burning very dirty coal. And that first cohort, we enrolled in 2002, and then a second cohort after the years after this, the plant had been shut down, a year after actually, and we compared the 2 cohorts. And here you see on the right, the first baby born into the first study, and the adducts were measured as in the other work that we've done. And then there's a child, I think the same child as you see in the top picture, taking the Gazelle test for cognitive development. And then down below, telomeres. I'll explain what we saw there. So comparing the 2 cohorts, pre and post plant shutdown, the ambient air levels of PAH were significantly reduced. We set up a monitoring system in the city, and that was a significant finding. The adduct levels also were significantly lower in the second cohort. That's in umbilical cord blood. And that we also saw improved birth outcomes. We no longer saw the significant associations we had seen in the first cohort between exposure and lower developmental scores on the Gazelle test. And levels of brain-derived neurotrophin, BDNF, were significantly increased in the second cohort. And telomeres in cord blood were significantly longer. And telomere length is a kind of general indicator from a number of epidemiologic studies, general indicator of health and longevity over the life course. So this was taken together at the ambient level, the molecular level, clinical level. We saw some evidence of benefits of the coal plant closure in Chongqing Municipality, and we've followed that up now. How many minutes do I have? Okay. We've followed that up with, okay, thank you. Great. We've followed that up with some work in Shanxi province, which is the main coal burning and coal mining area of China, where we've enrolled successive cohorts for the past 6 years to be able to look at the impacts of policy changes in that province over time as they've shut down coal burning facilities and the air has been cleaned up. And we think that we'll be able to record some benefits there too. And I should mention, and I haven't had time to mention all the collaborators, but you'll see on the slide, Tang Deliang is the key person in this work from Colombia, working with Chinese partners. Now, we know that there are huge health costs of air pollution and climate change, and these are all annual costs, up to $800 billion a year in health costs due to fossil fuel-produced electricity. In the OECD, and that's globally, in the US, excuse me. And then in the OECD countries, India and China, that price tag is 3.5 trillion every year. In London, the health costs have been estimated to be 4.8 billion US equivalent every year, and in China, 69 billion in 2005. And then for climate change-related events, 14 billion in health costs just from 6 climate change-related events in the U.S. And we know that the toll and the price tag has been mounting, as we've seen with Hurricane Katrina and Sandy and all the others. Solutions do exist, and they are working. They're on the ground working. Regulations and policies on air pollution and climate change. And remember, because they come from the same, the problems are emitted from the same source, the solutions generally do work. If you would intervene on air pollution, you're going to mitigate climate change and vice versa. Shifting to clean modes of power and generation and industrial productions, and shifting to low-emission vehicles, which is very, very important. And then buildings and making cities more compact, energy efficient, and more livable. Urban transit, walking, cycling networks, and rail interurban travel. These are all working on the ground now, and many of them right here in California, which is certainly leading the country and much of the world as well. So there are estimated economic benefits of current initiatives. We often cite this $2 trillion a year in avoided health costs by the U.S. Clean Air Act amendments, estimated to occur by 2020. The Regional Greenhouse Gas Initiative in 9 northeastern states, $5.7 billion in public health benefits. California Climate Change Initiative, $8 billion in avoided health costs by 2025. And then the retirement of 150 U.S. coal plants, $1.8 billion in avoided health impacts. But there's a big but. These benefits assessments omit many significant outcomes in children, and they undercount the health and economic benefits. So these assessments that have been done and costed are really very, very narrow. And we can do better by incorporating those benefits to children. So in New York City, we have a project going on monitoring policy interventions that were laid in place during the Bloomberg years, 2002 to 2012, but continuing to clean up buses. Dump dirty diesels was the campaign slogan, cleaner taxis, clean heat, to improve air pollution. And we're looking at how those policies have affected the air quality in New York City, the relationship between trends in air quality in the city to the trends in childhood illness using population data, and also our cohort data. Remember, we have been tracking these kids, one more minute, from 1998 through the present, and our benefits shared equally. That's one of the key interests of this policy. So we see some encouraging signs. This is the particulate matter 2.5 monitored at the birth residences of the New York City cohort, and they did decline from 2000 to 2016, so that's good news. Here are the data from the backpack monitors. Also see a trend in that purple line, downward trend, in levels of PAH from 1998 to 2012. So the initial results are encouraging. And the last example is a case study we're doing in Krakow, Poland, with our colleagues there, where we also have a cohort enrolled, 350 to 400, I think, mother-newborn pairs enrolled in 2000 and being followed. And there have been policies to restrict coal burning. They've shut down the major industrial sources, but the burning of coal in homes, such as you see in that photo, has in recent years been the main contributor to the smog in that photo on the upper right. And largely due to this campaign, Smog Alert, that you see here on the left, the government has been pushed to close down this source of residential coal burning, subsidize cleaner energy, And you can see a trend downward, but the ban is not yet it's going to occur next year, so we expect to see a good drop, and we'll be able to monitor that at the level of the population in Krakow using citywide data and also within our cohorts. So to summarize, we do see multiple effects. Those have been documented of fossil fuel pollution on child neurodevelopment, and that's true globally and in the US with this disproportionate burden of children. And multiple health benefits can be gained from reducing our dependence on fossil fuel, both health and corresponding economic benefits. We need child-centered policies on air pollution and climate change that consider the problem holistically. And I think it can be said to be, as Lancet did, the greatest challenge and the greatest opportunity of our time. And I must acknowledge the many collaborators and investigators who made this work possible, both at Columbia, at Community Partners We Act, and other groups mentioned here, and also our funders. And thank you very much.